So I want to finish up carbohydrates, look at a couple of reactions. Again, we're going to look at monosaccharides. So monosaccharides are glucose. This is a glucose, fructose, etc. So the ones we've been looking at are actually monosaccharides. And this one right here, this is oxidation, actually. This is going to be oxidation of a monosaccharide. The reason we know that, say this right here is actually glucose. Let's take a look at glucose. It has 1, 2, 3, 4, 5, 6. It has 6 carbons in the chain, and it's an aldehyde. So it's actually, let's look at this too, it's actually going to be a D version. So it's actually D, you can say aldohexose, but everybody calls it glucose. It's actually D-glucose. And in nature, most of these sugars are going to have the OH on the right-hand side. So that's going to be the D form of it. So it's an aldehyde. It undergoes oxidation. So this is actually called Benedict's reaction. And I'll try to do a demonstration of this if I can. It reacts with some type of carbon or a copper 2 complex. Copper is usually blue, so copper 2 is blue. When I reacted, notice that this aldehyde undergoes oxidation. You form a carboxylic acid. So just being able to identify it. You go from an aldehyde to a carboxylic acid. Everything else stays the same, by the way. I'm just looking at carbon number 1. So this is carbon number 1, 2, 3, 4, 5, 6. So I gain an oxygen, so that's undergo oxidation. This copper positive 2 actually undergoes a reduction. I'm not worry too much about it. But it forms a brick red complex. So basically what's going to happen is you have a test tube. It's going to be blue. You do the reaction, you're going to end up with a nice red color. So that's characteristic of a Benedict's reaction. The main thing is this glucose undergoing oxidation. Look at carbon number 1. It goes from an aldehyde to a carboxylic acid. So let's kind of finish this up. Again, this is going to be glucose. In this case, it's going to be undergo reduction. The way to know this, let's go ahead and label these carbons. So 1, 2, 3, 4, 5, 6. So again, glucose is an aldehyde. So when you do reduction, remember you added hydrogen. So hydrogen, a lot of times you add a catalyst like platinum or something. This is kind of speed up the reaction. So let's go to the final product. Let's look at carbon number 1 again. So when we look at these reactions of monosaccharides, it's the carbon number 1 that undergoes the reaction. In this case right here, notice that it's picked up a hydrogen. It's picked up a hydrogen here, and it's picked up a hydrogen there. So it's gained hydrogens, so it's undergo reduction. So if it picks up hydrogen, it's going to be a reduction. We go from an aldehyde to an alcohol. So if you go from an aldehyde to an alcohol, it's reduction. Aldehyde to carboxylic acid is oxidation. This right here is actually a sugar alcohol. Sometimes they'll call this, I think it's alditol. I'm not 100% by that. So sugar alcohols are used in sugar-free candy, etc. And the reason is it's not going to raise your glucose blood sugar because it's not glucose, and it's not going to make tooth decay. So again, these sugar alcohols are good. They're not going to cause tooth decay, and they're not going to raise your blood sugar level. So again, let's be able to identify this is a reduction. So you go from aldehyde to an alcohol. So if you make a sugar alcohol, you're just going to react with hydrogen, the glucose, and end up with an alcohol.